Assalamu alaikum dear students, welcome back to multivariable calculus series. Today we move on to one of the most fascinating topics in multivariable calculus, and that is quadric surfaces, section 11.7. Quadric surfaces are the three-dimensional counterparts of conic sections that you may already have studied. Just as conic sections include circles, ellipses, parabolas, and hyperbolas in 2 dimensions, quadric surfaces extend these ideas into 3 dimensions. So, by the end of this lesson, you will be able to recognize the different types of quadric surfaces, identify them from their equations, understand the effect of changing coefficients, sketch their basic shapes, and use cross sections or traces to visualize complex surfaces. So let's begin. A quadric surface is the graph of second degree equation in the variables x, y, and z. These equations involve terms such as x square, y square, z square, and sometimes products like xy, xz, or yz. So the general equation of this type is ax square plus by square plus cz square plus d xy eyz plus fxz plus gx plus hy plus iz plus j is equal to 0, where a, b, c, d, e, f, g, h, I, j are constants. But in this lesson, we will focus on the standard form of the most common quadric surfaces, which can be obtained by translating and rotating this type of equations. So, we'll be discussing the type where all the variables have only square terms, or two variables have square terms and one variable have a linear term. So, in order to understand such surfaces, cross sections or traces play an important role. A cross section is a shape obtained when we slice the surface with a plane, whereas trace is the specific type of cross section, and this is the shape obtained when we slice the surface with a coordinate plane or a plane parallel to the coordinate plane. The idea of using traces to draw a surface is employed in three-dimensional graphic softwares for computers. In most such softwares, traces in vertical planes x is equal to k, y is equal to k are drawn for equally spaced values of k, and parts of the graph are eliminated using hidden line removal. Okay, let's learn this method with the help of examples. So we have first example: use traces to sketch the quadric surface with equation x square plus y square over 9 plus z square over 4 is equal to 1. So this is this type of equation where all the variables have squared terms. Or you can generalize this form as x square over a square plus y square over b square plus z square over c square is equal to 1. So here a is 1, b is 3, and c is 4. So if we find the trace with the xy plane, that is z is equal to 0, then we have this equation x square plus y square over 9 is equal to 1, and this is an ellipse. Similarly, if we substitute z is equal to k, that is the trace of this surface with the any vertical plane, a horizontal plane, then this is also an ellipse provided k lies between negative 2 and 2, because this has to be greater than 0, otherwise it has no graph. So for this to be greater than 0, k should lie between this range. Similarly, vertical traces are also ellipse. When we substitute x is equal to k, we get an ellipse for the values of k between negative 1 and 1. Y is equal to k also gives us equation of ellipse where k lies between negative 3 and 3. So consequently, we have this type of surface, as you can see, and this surface have a close look in this figure, and this is known as ellipsoid. All the traces of this surface are ellipses. So this is known as ellipsoid. So whenever we have equation x square over a square plus y square over b square plus z square over c square is equal to 1, and a square, b square, c square are not all equal, then this is an ellipsoid. And this is symmetric about the coordinate planes and coordinate axes as well, because it has square terms only. This is another view, and you can see this type of shape around you. American ball, rugby ball, or egg-shaped object. So all these resemble ellipsoids. And if in this equation a square, b square, c square all are equal, then this becomes a sphere. Okay, let's have another type of surface. So here you can see one negative sign. So if we have a surface like equation like x square over a square plus y square over b square minus z square over c square is equal to 1. That is one all square terms but one negative sign and two positive signs. Then its horizontal traces are ellipses. That is, when we substitute z is equal to k, we get ellipses. And its vertical traces are, that is, for y is equal to k and x is equal to k, we get hyperbolas. So it's this is how the traces, horizontal traces looks like, and whereas the vertical traces are hyperbolas, right? So this is called hyperboloid of one sheet. Yani one negative sign gives us hyperboloid of one sheet. So if we have this type of equation, x square over a square plus y square b square plus z square over c square is equal to 1, but one variable has negative sign, then we get hyperboloid of one sheet. This is a closer look of this type of surface, and its examples are cooling towers or shape of glass tower, look like this. Okay, we have another type of surface where two square terms have negative signs, one square term has positive sign, and its horizontal traces are ellipses and vertical traces are hyperbolas. So this type of equation has a surface which consists of two separate pieces. So there is a gap between the upper and lower sheet. So that is why this is called hyperboloid of two sheets. So when we have two negative signs, then the surface is hyperboloid of two sheets. When we have one negative sign, we have surface which is called hyperboloid of one sheet. And if we don't have any constant term, all the terms are square terms, and we can write the equation in this form: z over c square is equal to x square over a square plus y square over b square. Then this is called elliptic cone. If a square and b square both are equal, then the cone is called circular cone, and otherwise it is called elliptic cone. And it also has two parts, but both the parts are connected at one central point. You can see here. So if z square over c square is equal to x square over a square plus y square b square, so axis of symmetry is z axis. But in case we have equation like this, y square over b square is equal to x square over a square plus z square over c square, then axis of symmetry will be y axis, and shape of the surface will be this. Similarly, we can have an equation x square over a square is equal to y square over b square plus z square over c square, and in this case axis of symmetry will be x-axis. So another type of equation where two terms are square terms, or two variables are squared and one of the variables is not squared, that is linear, and we can write the equation in this form: z is equal to x square, or you can write z over c is equal to x square over a square plus y square over b square. So let's identify this type of surface. If we substitute z is equal to k, then we have horizontal traces, and that would be ellipses. Okay, and for x is equal to 0 we have parabolas, for y is equal to 0 we again have parabolas. So its vertical traces are parabolas and its horizontal traces are ellipses. So we can draw this surface like this. And in case we have z is equal to negative 4x square minus y square, then this will open downwards. Same paraboloid will be opened downward. And this is called elliptic paraboloid. This is called elliptic paraboloid. It's vertical. It's both the it has vertical traces, parabolic vertical traces, and horizontal traces are ellipses. So this is called elliptic paraboloid. And this is the equation where both the square terms have same signs, positive or both are negative. If both are positive, it will open upwards, and if both are upward means towards positive z-axis, and it will open downwards, that is towards negative z-axis, if both the signs are negative. And in case we have equation like y over b is equal to x square over a square plus z square over c square, then its surface will look like this. Axis of symmetry will be y-axis. We have another type, and its general form can be written as z over c is equal to y square over b square minus x square over a square. So one of the square terms has positive sign and other has negative sign, and it has two square terms and one non-square terms, that is linear term, and its horizontal traces are hyperbolas, whereas vertical traces are parabolas. So if x is equal to 0, z is equal to y square. When y is 0, z is equal to negative x square, that is open downwards, whereas this is open upwards. And the horizontal traces are hyperbolas. So this is called hyperbolic paraboloid. So in previous example, the shape was called elliptic paraboloid because it had horizontal traces, elliptic horizontal traces, but in this case we have hyperbolic horizontal traces and vertical traces are parabolas. So this is hyperbolic paraboloid. And it looks like saddle at this point, right? So this is how you can visualize it. So this is another view of this type of surface. Okay, now we can summarize this discussion, how to identify these surfaces. So if we have an equation like x square over, which can be converted in this type, x square over a square plus y square b square plus c square is equal to 1. That is, it has one constant term, rest of the terms are square terms, and all have positive signs. Then this will represent an ellipsoid. Whereas this type of equation, if this type of equation has one negative sign, then this is hyperboloid of one sheet. If it has two negative signs, then hyperboloid of two sheets. And if there is no constant term and all the squared terms are there, z square over c square is equal to x square over a square plus y square over b square, then this is the elliptic cone. And if we have two square terms and one non-squared, that is a linear term, z over c is equal to x square over a square plus y square over b square, then this is elliptic paraboloid. And if in this form of equation we have one positive sign, one negative sign of square terms, then this is hyperbolic paraboloid. So all these surfaces have axis of symmetry z axis, so we can identify the surfaces with different axis of symmetry as well, as we have already discussed in previous slides. Okay, if you have an equation and you have to identify the quadric surface, then you should ask the following questions. Number one, which variables are squared? Number two, how many positive signs are there? Number three, how many negative signs are there? Number four, does one variable appear without being squared? And finally, what do the traces and cross sections look like? Answering all these questions usually identifies the surface immediately. Okay, let's practice this with the help of examples. So we have this example. 4x square minus y square plus 2z square plus 4 is equal to 0. This is the equation of this type. But in order to identify, it has all squared terms, x square, y square, z square. There is no single variable term, and it has constant term as well. So it should be an ellipsoid, or it can be hyperboloid of one sheet, or it can be hyperboloid of two sheets. So let's see what is this. So first of all, convert this into this form. X square over a square plus y square plus minus y square over b square plus minus z square over c square is equal to 1. So in order to make right side 1, bring this 4 towards right hand side and divide the equation by negative 4. So we have this equation. Negative x square plus y square over 4 minus z square over 2 is equal to 1. Now in this case, you can see that it has two negative terms, right? So it should be hyperboloid of two sheets. But this is x-axis, this is y-axis, this is z-axis, and positive term here is for y square. It means axis of symmetry would be y-axis. So this is hyperboloid of two sheets. So one piece would be there and other piece would be similar piece would be there. So it will look like this. So let's find out by finding the traces, and let's see what happens. So these are the traces. If y is equal to k and if x is equal to 0, we have hyperbola. If z is equal to 0, we have hyperbola. And in case we have y is equal to k, then it has ellipses. So this is the graph of this. Okay, let's identify this. Now, in this case, we have x square term, we have z square term, we have y, we have x. So we can complete the square by using x square and negative 6x. And we'll write, we'll transform this into this form. Y is equal to x square over a square, y z square over b square. So I am writing uppercase letters here because there will be some translation. So if we complete the square of x terms, we'll have x square plus minus 6x, and let's add half of the coefficient of square of half of the coefficient of x, that is 3 square 9 plus 9 and negative 9, and that will give us this. Y minus 1 is equal to x minus 3 square plus 2z square. You can transform this equation into this form. Now this is uppercase y I was talking about, and this is x square plus 2z square. Z is same as the z we have in equation. And we can identify this type of surface as elliptic paraboloid. So elliptic paraboloid looks like this, or looks like this. Since this linear term is y, so it will look like this, right? But its turning point would be x is equal to 3, x minus 3 is equal to 0 gives us x, y is equal to 1, and z is equal to 0. So turning point, this point would be 3, 1, 0. That is x in xy plane, where x is 3 and y is 1. So this is how the paraboloid will look like this. Okay. So I hope you'll be able to understand the quadric surfaces, and you know how to identify them and how to sketch them with the help of the tools we have discussed in this section. So keep practicing and take care. Till next time. Bye.